So the topic of this talk is going to be performance beyond page load. I'm glad that Jeffrey gave a real good introduction about the networking performance. So when you say the performance of a web page, it's divided into two components, that is networking performance and the rendering performance. While networking performance takes care of your page load time and the start render time, your rendering performance will be taking care of the performance of your interactions on a web page. So that is what we'll be focusing upon. Our goal will be to build smooth interactions and even to understand as to what the issues are, if there are any with your web page or your interactions on your web page, and how you should take care of them. So let's start on. We start off with a small survey. I guess with a show of hands, you can actually tell whether you belong to it or not. So my first question will be, how many of you like animations in material design? With a show of hand. Okay. Some people, not all of you, but I guess it's mostly related to the fact that animations haven't been performing very well on HTML, right? Or it may be performing well on native devices, but not on your mobile, in the mobile browser. So we are going to tackle such issues in the coming slides, and I'll be discussing them briefly. So you won't like animations if they are not smooth. Our goal will be to make sure that we have these things in place, we follow the best practices, but some people want to term it like hacks, right? Because it's not up to you to actually take care of them. It should be it should be for the browsers to actually make it sure that whatever you have put in your code actually is performant, and when it runs on the web browser, it runs performantly. That is at 60 FPS. So there's a mix and match of different things that I'll be talking about. They are hacks, and there are best practices, and we'll be discussing them. So starting off with rendering performance, I just told you about the goal, which will be to build smooth interactions. So let's start with the case study. Our case study is basically about a girl and a boy, where the boy asks the girl to marry him. He proposes her, and luckily, he's responded with an answer which is yes. So what next is shopping. Shopping for that shopping for that wedding, basically. And it is e-shopping, that is the bridal couple is shopping on a mobile website, okay? Though what happens next is something that we didn't anticipate for, but it is something what happened. So this is the reaction of the girl after she was, going through the mobile website and trying to purchase from over there. So it doesn't look happy, right? So we need to make sure that this reaction doesn't happen for your own customers as well. So the bad performance of shopping portal, it leads to, though I need to tell you that the bad performance is basically the rendering performance and not the networking performance that we'll be discussing over here. Over here, we are talking about the interactions that are there on a web page and how they affected the experience of that particular bride. So this is that followed next after that particular reaction. This is basically a meeting between developers, project managers, and the testers to understand as to what went wrong or what can be the solution for improving the rendering performance of their mobile web application. So I'm not actually going to focus upon just the mobile web experience, but it will be the performance, it will be the rendering performance in general, okay? So wait, so as far as now, I have just told you about the case study in general. It was simply about the experience of the customer, how it impacted, what are the different things that people are thinking about. But let's take a technical perspective regarding this and understand as to what exactly happened, what is the technical issue around it, what is it because of, and what are the different solutions that you can actually use to overcome it, okay? So a small commercial break. This is about me. My name is Apoorv Saxena. I hail from India. I work as a full-stack engineer, and you can follow me at Apoorv_Saxena. If you have any sort of questions related to performance, whether be it a networking performance or the rendering performance, you can simply tweet up to me, and I'll make sure that I'll try to answer that. The companies that I've worked with and I'm working with, Wingify, Before that, I had worked with LinkedIn, which is now SlideShare, which is now LinkedIn, and Director. Some other conferences that I've contributed to before, the talks mostly were focused upon performance, but it was more about networking and even a bit about gaming performance. So in case you want to check them out, please do. So let's start off with basics, OK? So when I talk about basics, I actually come to this, I remember this picture from my childhood, which is about a bioscope. So with a show of hands, how many of you understand what is a bioscope? OK, just 1, 2, 3, OK? Not a lot of people understand what is bioscope. So basically, it's a small device where there are different stills of a particular animation or a movie, and they are moved manually by a particular person who is the owner of this particular device. And people will be able to look through these holes that you can see, the aluminum shells. And through that, when a person moves those stills, it appears like an animated movie. So on the right, you are able to see the stills of the animation that is played by the particular person, and that's how it is. So this is a similar concept that is followed when you even display a particular picture on a screen. So what happens is that the devices refresh their screen at 60 frames per second. And that is how they say that they are able to display at 60 FPS, or even more than that, like 120 FPS. So what is happening is that there are 120 frames per second that are played on a particular screen. The frame budget that comes to us to make our particular operation is 16 milliseconds. How we did this calculation is that in 1 second, you have to display 60 frames. So you do a simple calculation that is divided, and what you get is 16 milliseconds. So in 16 milliseconds, you have to make sure that everything or every operation that you're performing is under 16 milliseconds. If, in case, it exceeds 16 milliseconds, then you'll be able to encounter something that you won't want to. Though there are also some other householding works that a browser needs to take while carrying out your operation, which leaves you with just 10 milliseconds in total. So you need to actually make sure that whatever operation you are performing is completed in 10 milliseconds or less than that. And 10 milliseconds isn't a lot of time. When failing to meet 10 milliseconds, we come across a behavior which we don't like, which is termed as jank. Okay? So if there's a scroll that you are doing and you see that there's a lag in between, what you will term it with will be jank. So this is the experience that I was talking about. A person is trying to scroll the page, but he sees that it's actually not scrolling. The reason for it is that some operation is taking a lot of time, okay, which is not allowing the page to paint, okay, and because of that, he actually sees that there's a jitter or a lag, or basically he's encountering jank. So let's understand as to how a browser renders a particular web page, or how a CSS operation is applied onto a web page. So the pixel pipeline comprises of these 5 stages, if I may say. It starts off with JavaScript, because most of the interactions may trigger from JavaScript. It can also via CSS also, which is the second stage. But let's think that you have made some sort of interaction, and it goes to your JavaScript, okay? What happens is that you do some sort of DOM manipulation, which basically creates a corresponding style, and it is passed on to the next stage. Following the style, there are 3 sort of operations that can be applied depending upon the CSS rule that is applied from the style stage. And these 3 operations are layout, paint, and composite. I'll be briefly describing each one of them as to what they do, what are they responsible for, and what impact do they have on performance. So first comes in is layout. Layout is an operation which is triggered when you reposition or you change the size of a particular element. So that basically triggers a layout operation. So as you can see over here, this is a particular web page where I have highlighted the boundaries of element, and whenever you do some sort of change on the size or the position of a particular element, the layout operation will be triggered in the pixel pipeline. After the layout operation, paint operation will be triggered, and after paint, it will be the composite operation that will be triggered. So layout will be the most expensive operation when it gets triggered. The CSS properties that are responsible for triggering the layout operation are all of these. So you can basically go to them. I'll tell you as to what site you can go to and understand as to what CSS property corresponds to which operation, or what operation does it trigger. So over here, you'll be able to see the CSS property. For example, width. It basically changes the size of a particular element, and thus is labeled under the layout operation category. That is, it triggers a layout operation. Comes next is paint. What is paint operation? So the paint operation is about when the pixels of a particular element are changed or they need to get repainted. That is how we define a paint operation. So when you actually see that an element's layout has been changed, that is, its size or position has been changed. So inside a web page, there might be some elements, right, which are getting their pixels repainted. So that is why the paint operation is triggered after layout. But there are CSS rules that allow you to just trigger the paint operation. So let's understand that. Over here, you can see that paint comes after layout operation, but it can be triggered via CSS property directly also. So this is a simple screenshot where you can see different colored pictures. Though the CSS property that is responsible for triggering a paint operation, just a paint operation, I'm not saying about the layout, are color, background color, and all of these CSS properties. They all are responsible for triggering a paint operation directly. Okay? The next comes in is composting. Composting is an operation which allows a browser to basically composite different layers together and render a web page. It comes the third in all of these operations and the last in the pixel pipeline. Okay? So first comes in is the layout operation, comes next is paint, and then composition, where all of the layers are composted together. So this is how you can picturize a web page. There are different layers on a web page, and upon the rendering of a web page, or when there's a change, the last step that happens is this, the composition of different layers to render a web page. So this is the order of what the performance impact of different operations have in a pixel pipeline. The most impacted or the most expensive operation to perform is layout, followed by paint, and followed by composite. The reason being that layout triggers paint and composite as well. Paint just triggering itself, but composite as well. And composite is the last operation, which is triggered by CSS properties like transform or opacity. So you might have heard of people saying that you should use CSS3 animations, or you should use CSS3 transform instead of using JavaScript, or instead of using some other paint operation. So the reason is that only the composition operation is applied in case of transform and opacity change. Okay? So how do you analyze the performance of a web page? Now we have understood our theoretical knowledge, right? That there are three sort of operations. But let's try to do something practical. So the thing that we need to understand as to how we can analyze our web page is first is an FPS meter. I have mentioned about the Chrome Dev tools because it has a feature that it is able to display frame rate on a particular web page while you're doing different sort of interactions, though they are readily available in different other browsers, and you just have to see for it. There are several other libraries also that you can include in your web page, and you can actually see as to what frame rate is running for while you're doing some sort of interaction. So this is the screenshot where you can see on the top right, I have my frame rate which is running. When I enable it on Chrome, I'll even display as to how you can enable it by yourself, though it's simply, I have made a screenshot where while doing an interaction, I was able to see that the frame rate was dripping even below 30 FPS, which was the reason of the jank to come in. Next comes in is enables paint flashing. So what does paint flashing allow you to do? It allows you to see as to what all elements are undergoing a repaint. Okay? So when you see a lot of paint operations happening while you're doing some sort of interaction, you'll be able to see as to whether a particular element that you wanted to repaint is repainted or not, and what other components are affected. Because you might trigger a layout operation which can further repaint all of the elements on your web page, and which is a warning sign for you, right? So this is how a web page looks like when you have enabled flash painting, and you can see a lot of elements getting repainted. The site that I've audited it for, it was materialup.com, and as of now, so I'll be explaining as to what was the reason behind it, because of this situation to comment, where you can see the entire screen to get repainted. The next is Chrome Dev Tools timeline. So the timeline allows you to actually see as to what all operations are performed when you do a record of a particular timeline, or when you do a record of the interactions for your web page. So this looks something like this, and what you're able to see below is that there are different frames that you can see. And with every frame that is exceeding the 16 millisecond window, you can actually see them going above 30 frames per second line, which is the topmost in this. Okay? Below that is 60 FPS. So over here, you can see that at a lot of times, JavaScript is taking a lot of time, and because of that, the next operation that happens, which is paint, is taking its own time, which is because of which the total time taken in a single frame exceeds 10 millisecond or 16 millisecond in total. This is the reason for you to understand that a jank is happening. So what are the performance best practices? As I mentioned earlier, you might want to think of it like best practices or even hacks. But yeah, if you want to make your customers' experience smooth, then this is the way to go forward with. So first in this is CPU versus GPU. So CPU is not efficient in handling the graphics-related operations, while GPU is built for it, right? So we need to understand that JavaScript utilizes CPU, which is followed by GPU when it is manipulating style. So what you want to avoid is using JavaScript to trigger style operations or to manipulate your DOM. So in those cases, you'll want to use CSS instead of using JavaScript. Though with the animation API coming, the web animation API coming to JavaScript, it will be hardware accelerated and it will be using GPU. Though its support is very limited as of now, and still in the beta stage, it's not very stable. So it's yet to be there. So as of now, you can think of using styles for manipulating your DOM instead of JavaScript. A rule of thumb is as simple as that. Use classes to update element styling instead of using JavaScript. An example for this will be the following code, where earlier in the first part, I'm using CSS, and I'm removing and adding classes to basically apply some sort of style to a particular element. In JavaScript, what you'll be doing similarly, when not using CSS, will be something of this operation, where you define as to what are the properties you want to change, and you simply apply, change the style of the JavaScript element. The process that's followed is comprised of another step in JavaScript, which is rasterization, and which takes a lot of time and is continuously improved by the web browsers. Though when you compare it with how CSS is doing it, it's a lot more performant. So style calculations. The reference will be CSSTriggers.com. So let me open it up. Over here, CSS Triggers is a great contribution by a developer advocate by the name Paul Lewis. And what you can do over here is you can see as to what CSS property triggers what all operations. So if I write in the filter over here like color, so you can see that it triggers a paint operation followed by a composite operation, right? And it doesn't trigger a layout operation. If you change it to width, you'll be able to see that it triggers a layout operation followed by paint, followed by composite. I'm not asking you to mug these CSS rules and their corresponding operations, but have a thought about it so that when you are using it in your daily workflow, you'll be able to have that particular understanding, and gradually it can become a habit. So you are so you have a better understanding as to what CSS property applies what sort of functions, what sort of operation, and what performance impact it has on your web page's performance. Coming back. So these are some of the things that one must follow. One needs to really understand as to what impact rendering performance has on their web page, or how is their rendering performance. So what you need to do is you need to profile. You need to profile your page. You might not want to go to the extent of using timeline, as I displayed before, but you might want to actually see as to what all elements are getting repainted upon some sort of interaction. I guess while you are doing a code review, you can look for these subtle things and maybe help each other to do it better. And that's how you can make it a habit. Comes next is choosing your CSS rules wisely. Once you are able to understand as to what the issues is, you will be able to see as to what is the CSS properties that are getting applied when you are making some sort of operation. And you can see as to what operations are triggered, that is layout, paint, or composite. And depending upon that, you can take decisions whether some sort of operation is possible in an animation or not, without having less than 30 FPS or 60 FPS. Next comes in is avoid triggering layout/paint operation repeatedly when animating. So as I mentioned just before, when you're animating, try to just use the composite operation or the CSS property that only trigger a composite operation and not a paint, because that's really expensive. Comes next is prefer using transform and opacity, as I just mentioned. Next comes in reducing the complexity of CSS selectors. So this is a quote by one of the developers at Opera. And what they said is that when applying a CSS rule on a particular element, 50% of the time is actually spent on finding the particular element via the selector. So in case you are having a very complex selector, you might want to have it less complex, okay? And have it that way, because otherwise it will take a lot of time. I guess in the last slide, what he mentioned was that it was like maybe a 20 or even more than that, the selector, the entire length of the selector. And in those cases, it took a lot of time for the mobile to render that particular web page and apply that particular CSS rule on a particular element. So you need to make sure that you don't go into such cases, especially when using preprocessors, for example, SAS or less, right? So this is a small example. Over here, I've mentioned a class where I'm applying some sort of rules, which is .title. And on the next side, I have a box, which is the parent element. And on the last child, I'm having, inside it, I have the title div, or an element which is having a class. If I can basically use .title, instead of using this sort of CSS selectivity, I should use .title. Okay? Because it's a bit more performant. Now, the next thing that comes in is that CSS selectors have already been optimized. I won't ask you to actually spend your time over this, but please make sure that you have an understanding about this. The next comes in remove unused CSS rules. The CSS selectors, as I said, are already performant, though if you have those CSS rules which are not used, browser spends a lot more time to see as to what element it needs to apply it on. So you'll want to actually automate this particular task of removing the CSS that's not used at all on your web page. So there are several tasks and plugins that are available, both for Gulp and Grunt, that you can use for removing the unused CSS rules. Comes next is reduce the number of elements being styled. So when a particular interaction is happening on a web page, please see to it that only the elements that need to be updated are repainted, and not each of the element on the web page is getting updated. An example will be google.com. We'll be sharing it later as to what all elements are affected with some sort of interaction. And you'll be able to understand as to how you can implement it on your web page also. Comes next is measure your style recalculation cost. So when you're animating, there's a recalculation that is happening with every frame. You need to make sure that the styles that you're applying on a particular element, when you're animating, they are not very expensive. An example for this is this. There is a LI, and I have applied a hover over that. I have an event bounded, on which I change the background color. Now, background color is a paint operation. So I need to make sure that that no other thing, or I'm not doing something in parallel which may exceed my frame window. An example would have been on canIuse.com when we perf-audited them. So what happened was that there were several li elements, and there was a hover property, and on top of it, the color was changing while we were hovering. And when we were scrolling the particular web page over those li elements, which had the background color change on hover property, it basically made it exceed the frame window of 16 milliseconds or the 10 millisecond window. So in those cases, we were able to see jank. And such is the case that you can find when you have a style recalculation on a particular event, which is happening repeatedly. Comes next is reducing paint area. Don't paint unnecessarily and avoid union of damaged regions. What I mean by this is in this picture, you are able to see that there are different elements getting updated. From the boundaries, you are able to see as to what elements are getting updated. Though, because the entire screen is getting repainted, what is kicking into place is union of damaged regions. So let's say that there are three elements on a web page which are big, and they are getting updated. So the browser says that instead of repainting just 3 elements, why not paint the entire page so that it takes a lot less time for me instead of repainting those 3 elements individually, one after the other, or simultaneously. So you need to make sure that something of this sort is not happening, because it might lead to a janky experience. Comes next is CSS Animations. As I mentioned before, you should use composite operations while you're CSS animating. A lot of other JavaScript libraries also capitalize on this behavior of browsers. For example, Famous. It simply uses transformation to make animations and run them at 60 FPS. So you might want to explore it further. Comes next is debouncing the input handlers. The input handlers can be even the actions or the association on a particular event. An example that I've taken is disabling hover event listener while scrolling. And this is the example that I made earlier. This is canIuse.com. And yes, you can see there are a lot of LIs. And on the right, you are able to see that there is a hover property in which I'm changing the color. So this was the reason that we were able to see a janky experience. And when we disabled that hover, we were able to see the jank being gone. So how you can do this is a simple hack that you can incorporate in your own web pages, is that when you're scrolling, you can actually disable all of the CSS hover events that are associated on a particular element by doing a pointer events none property on a particular class, and you can apply that same class on top of body. So when you're scrolling, you can add a class of pointer events none to the body, and it will make sure that no such hover property gets activated while you're scrolling. Once you're done with it, it will restore it back by removing that particular class, and you'll be in a situation, and you'll be in the normal behavior of your hover properties. Comes next, promoting elements that update frequently. We just saw a great talk about SVG animations. A lot of time what happens is that the animations are happening, and because of an animation, that element is getting repainted. Now, because that element is getting repainted, you might want to actually promote it to its own layer so that it's just composited. The time is actually not spent in repainting it again and again. But you need to make sure that whatever you are promoting is done after you have profiled and after seeing that it may affect your page performance. Because otherwise, you'll just you can do a similar thing where you can update, where you can promote every element to its own layer, right? But that will consume a lot more memory. So this is an example where you can see a particular image which is having its own layer, and the text which is after this. There might be some sort of animation that can be applied to the image which is displayed over here. So here's the fun fact. Did you guys know that position fixed elements and scrollable elements do get repainted every time you do some sort of interaction with them? So I guess a lot of us are using headers, right? Which are position fixed headers or fixed elements on top of a web page. In those cases, those elements get repainted. There are hacks. There is actually a hack which allows you to go over it and basically promote it to own layer, but you need to make sure that you have profiled it before you go ahead with it. So this is the hack that I was talking about. Will change transform is a CSS property that allows you to tell the browser that, hey, this element is getting repainted a lot of times, and you need to make sure that it's promoted to its own layer. The other hack is transform translate Z0. Though will change transform is available in most of the browsers, and as a fallback, you might want to use transform translate 0 as well. Both of their functions is to basically promote a particular element to its own layer. I'll basically go through a live performance audit so that you guys can understand as to what I'm telling in general as of now about the best practices, but follow along with me till we do a performance audit live. Comes next is GIFs and Performance. So GIFs and Performance don't go hand in hand, obviously because GIFs get repainted every time they have a new frame. So because of them, materialup.com, which is a great website about showcasing the material design projects, it was getting a lot of janky experience. It was able to see that lag in performance, in the rendering performance. The reason for it was that a lot of elements were getting repainted, and at a lot of time, union of damaged regions was what getting applied by the browser. So their entire page was getting repainted when the small GIFs were there. So this is an example, the screenshot that I took. Both of these are images, and when I enabled paint flashing, I was able to see that both of them were getting updated every time there was a change in the frame of that particular GIF. So you might want to disable GIFs once they are not in the viewport, so that they don't actually contribute to the impact of the rendering performance of your web page. So now it's time to do a live performance audit. So I've opened up this console of mine. I'm using Chrome DevTools. You can use any other browser DevTools that you want. It's a bit more simpler in Chrome, so that's why I'm using it. So as of now, you can see that I've enabled paint flashing, and because of that, you're able to see as to what elements are getting repainted. So let me go above and look out for its GIF animation. Okay. So now I'm not into the viewport, and you can see that a GIF is getting repainted every time it has a new frame, right? It's on the top right that you can see over here. Now, what you need to make sure that if such thing is happening on your web page as well, you might want to disable it by removing its source, by replacing it with another static image per se, or you can use some other technique. Comes next is show layer borders. So it allows us to see actually what are the different layers on a web page. It might not be making a lot of sense, but let me do something as of now. So over here, I'm interacting with this particular element, and I'm just scrolling up and bottom on this particular element. Can you see that entire list is getting repainted when I'm scrolling? It was a fun fact that I shared before, that scrollable elements get repainted. So this is something that you would want to avoid, that when you're actually scrolling a particular element, what is the need for the entire element to get repainted? So the hack in this case would be to simply inspect this UL and apply a will change transform property. Yep. And now when you scroll, you are able to see that the entire element is not getting repainted. So this is a hack that people say that it's a hack, but if you want to improve your page performance, this is something that you can incorporate as well. So this is it, and there are several other things that I just mentioned before that you can apply to do a similar thing. Over here also, there are, as you can see, the entire element is getting repainted, which comprises of different pics. So you might want to avoid this. So a similar hack that we did for Hacker News widget, you can do a similar one for Dribble as well. Okay? And after we have applied this particular will change transform property, I said that it has been promoted to its own layer. Now let's verify. Now when I say show layer borders, you are actually able to see a blue line on the hacker news widget, right? So this is because this element is now upgraded to its own layer. Now, actually, let me remove this will change transform, okay? And now let's show layer borders. Okay, I guess it has been already upgraded to its own layer. This is the reason for it. But otherwise, it would not display that blue border around that particular element. So coming back, at EdgeConf 2012, and I guess we are all aware about the rendering performance, that they have a serious impact about the customer's experience. So this is a case study which Facebook mentioned, that when it reduced the frame rate from 60 milliseconds, from 60 FPS to 30 FPS, they saw a decrease in the user engagement. So this is the reason that you should really think of improving your rendering performance of your web pages. Part 2 performance will be to practice it and make it a continuous habit. We have put in perf.audit.com, which allows you to actually see as to when we performance audit different web applications, we make them live so that developers like you can see as to how we performance audit it and do by the same by yourself. So this is what we intend to do with perf audit. We have also put in our documentation, which we are updating regularly, where you can see as to what are the different things related to rendering performance, what are the issues, what are the different articles that you should look out for when there's a particular impact of your web performance. So you might want to check out perf.audit.com in those cases. In case you have done a performance audit by yourself, you might want to ping us at perf.audit, and we'll be happy to add it in our repository as well. So that's it. Thanks, everyone.
I have noticed when we were working on animation on mobile devices, different type like iPhone 6, 6S, 5, there is difference in the lagging of performance when it comes to rendering. So do you have any idea why it happens?
So, so when you say that you are able to see a lag in performance, there are different reasons for it. And the way I would want to explain is that over in the slides over here, I simply discussed as to how CSS can impact your page performance, though it can be triggered via JavaScript as well. For example, there's a consecutive DOM read and write, which might be happening and impacting its performance. And there are several other issues that can be related to it. So the way that I did a perf audit for the rendering performance, you can do a similar for your own application and understand as to what is the thing that which is the reason for the jankiness in your case. It won't be a generic answer, but you need to understand as to what are the different issues that can impact your page performance, and that's how you can resolve it.
There is a way to debug this on native iOS, instead of using Chrome tools.
So
because in Chrome tools it does not show any difference, even when you try to reproduce it in the same way. But on native iOS devices, it shows the difference.
Okay. Because these issues are generic, they happen the same way on the desktop and the mobile devices as well. So I didn't actually had much difference between while analyzing the performance of a particular application on desktop and mobile. But I have to see in that case as to what is the exact thing which is making a difference between the two devices. So yeah, not sure about the exact case in that sense. Yeah.